Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and I'm excited to welcome you to part 6 of my basic RPG tutorial series. In this video, we're going to be fixing the movement just a little bit. We're going to be completely rewriting the movement because currently if you move at a diagonal, you actually move faster than if you move just straight up and down. So we're going to be fixing that. We're also going to be converting our movement system to an x-axis and a y-axis system instead of just the checks for left, right, up, and down. And the reason we're going to do that is because I'm going to also show you guys how to incorporate a game controller. For example, I have a wired Xbox 360 controller that I'm going to use, and I'm going to show you guys how you can incorporate that into this game as well, how you can bring that control scheme in, because that can really help your game to feel more like a game if there's a controller with it. So let's get started. The first thing that we're going to do is we're going to open up the player object. So come into Objects and Player. And open up the create event. Now we're going to give our player some new variables here. So we've got the speed variable. We're going to create two new variables. The first one's going to be called h speed, and we're going to set that equal to 0. And the second's going to be called v speed. We're going to set that equal to 0. And I'm just typing h spd and v spd. Because hSpeed is actually a built-in variable in GameMaker, and we can't use that because it doesn't work with the physics system. We'll mess it up. So what we're going to do now is, now that we've created those variables, actually we need to create one more too. We're going to create one called len, which just stands for length. We're going to set that equal to 0. So we've got h speed, v speed, and length that we've created. Now we're going to open up the move state for our player. We're going to use these variables, and we get to delete all of this code. Oh, so this was mostly to teach you guys the basics here. But we're going to remove that code. Get rid of all of it. We're going to reprogram that section. So the first thing we want to do is get the horizontal speed in the get the axis. Get the axis. So we're going to do var x-axis equals and var y-axis equals. So we're going to get an x-axis and a y-axis. When we eventually do move to the controller, this will be really easy because the controller functions literally return an x-axis and a y-axis. When we're using the keyboard though, because we're still using the keyboard right now, we've got to be a little bit trickier. So what we can do is we can do the x-axis is right minus, well, let's see, how did we, I think we typed these as right key, yeah. Right key minus left key. Now this is a little bit tricky, so let me explain it just in case. If we're pressing the right key, this is going to be equal to 1. If we're pressing the left key as well, this is also going to be equal to 1. So if we're pressing both right and left at the same time, it's going to be 1 minus 1. Because remember, in code, things eventually down at the lowest level are just zeros and ones. So this is going to be equal to 0 because it's 1 minus 1, which means 0. So if we're pressing both right and left at the same time, our x-axis is going to be 0, or right in the middle. Now if we're pressing right but we're not pressing left, this is going to be 1 and this is going to be 0. So 1 minus 0 is 1. So we're going to end up with an x-axis of 1, okay, which is to the right for you guys, I think. Now, if we're pressing left, this is going to be 1, and we're not pressing right, this is going to be 0. So 0 minus 1 is negative 1. So then our x-axis is going to be negative 1 or to the left. So it's a really clever way to get your axis. You can do the right key, subtract the left key like that. We can do the same thing for the y-axis. It is reversed here. Down key minus up key. Now the reason it's reversed is because, like I said, down is actually positive and up is negative inside of GameMaker Studio. So that's why these are the opposite of what you would think they would be. Okay? Now that we have the axis, we can move our character. So we're going to do move. We're going to do well, we need to actually create a horizontal speed and a vertical speed here. So we can do h speed equals x-axis times speed v speed equals y-axis times speed. Okay? And so this is get the h speed and v speed. And then we're going to have another one, which is move. So we're going to do physics position x plus equals h speed, physics position y, oops, that's x previous, physics position y plus equals v speed. Okay? So if our x-axis is 1 and our speed is 2, then our horizontal speed is going to be 2, right? If our y-axis is negative 1 and our speed is 2, then our vertical speed is going to be negative 2, and we'll move up and to the right. Okay? And we're just adding the horizontal speed and the vertical speed to our physics x and physics y position. So that should just move us. Now you're going to see we broke some stuff. Our character doesn't animate, and it actually still moves faster on diagonals right now than it does just normally. But we can move around in the room. Everything else works again. And, I mean, it's nice because if you press both left and right at the same time, the character won't move, or both up and down. Just stays there. So we need to do a little bit more to fix this move state. So one of the things we need to do is we need to use the axis to get the direction we're going to move in. And there's a function for that we can use. So I'm going to hit enter here, and we're going to do get direction. Now, this is going to start to get a little bit more complicated than the other tutorial videos. This is a build-up series where we're going to start out really simple and kind of build up. It's going to get gradually more complicated, but I'm going to do my best to try and explain it to you guys. If you have questions, I am reading all of the comments. So post the questions in the comments. I'll do my best to answer them. I'm not answering every single comment like I used to because there's too many comments that I'm getting. But I do answer every single question. So if you have a question or an error message, post it. I will do my best to help you. So we need to get the direction, and we're just going to create a temporary variable called dir, which stands for direction. Because again, actual direction is a built-in variable and it won't work with physics. So dir equals, and then there's a function that we can use, point direction. And there's another one called point distance. Make sure you get point direction, not point distance. Now we need to use our x-axis and our y-axis to get the direction. And the point direction function takes two basically points in the room. You give it 1 point, like an X and Y coordinate. Then you give it another point, another X and Y coordinate. And then it measures the direction between those 2 points and gives you that direction, whichever direction it is. And directions are go 360 degrees. So to the right is 0, up is 90, left is 180, and down is 270. And then you get back to 360 or 0 at the right. So that's how the direction system works. So we need to pass in some X and Y coordinates. To make this easy though, we're just going to do 0 and 0 for our first coordinate, right? 0, 0, right in the center, or technically in GameMaker it's the left corner, but. And then we're going to do X-axis and Y-axis, okay? And that's going to use the X-axis and the Y-axis to get the direction that we should be moving. Now that we've got the direction, we need to get the length. Get the length. And we can use the direction plus our speed to get the length. Well, actually, we just use our speed for this, but we can do if x-axis is equal to 0 and you can do that both ways. You can do 2 and % signs, or you can actually type out and. I have been typing and, so I'm going to try and continue to do that if I can remember. So really quickly, I want to explain something. You see how I use 2 equals right here to check if x-axis is equal to 0? And up here, I'm using 1 equals when we set x-axis equal to whatever the result of this is. Those are actually 2 different things. This is called the assignment operator. And what it does is that it assigns the value to the right, whatever this is equal to the value to the left, right here. So it's assigning. It's kind of like the statement, okay? The single equals is the statement. Down here where I've got the 2 equals, this is kind of like the question. It's like, are these equal? And it's called the comparison. The assignment and the comparison, I think. For some reason that sounds wrong to me right now. It might not be the word that I'm looking for. But what it does is it checks to see if these 2 values are already equal to each other. Okay? So they are different and they kind of mean different things. This one is always in a question like if, right here. And this one's always just in a statement. So that's how you can remember the difference. So we're checking to see if our x-axis is 0 and our y-axis is equal to 0. Because if they're both equal to 0, then our length is going to be 0 as well. Because we're not actually moving. And there's an easier way to do this, but it's without if statements, but it's a little bit more complicated to explain. This seemed a bit more straightforward. So length equals 0, else length equals speed. So we're just going to set the length to our speed. Now that we have the direction, we need the length that we're going to move, and we just want to set it equal to our speed. Okay? Now we need to change this section right here where we get the horizontal speed and the vertical speed, because this isn't actually the best way to do that. When we just times the x-axis by the speed and the y-axis by the speed, that's what causes us to move faster at diagonals. So there's a special function that we can use inside of GameMaker that converts a length and a direction into basically a horizontal speed. And the function is called length underscore, length dir underscore x. Okay? And you can see this function takes a length and a dir, or a length and a direction, a dir. So the length we already have is length, and the direction we already got as well is direction. So we already did the preparation work right here where we got the length and got the direction. This is the preparation work that we needed to do in order to make calling this function easier. Now we can do it with the same for the vertical speed, but we want to do length dir y instead of x. Length dir. Okay. So this just converts a length and a direction into a horizontal speed and a vertical speed. And the benefit of this is that a horizontal speed and vertical speed will be slightly less if we're moving at a diagonal. So we won't move faster. Now we should be able to run the game. And you'll see that when we move on angles, we don't actually move faster anymore. So we're moving the correct speed on angles now. Now what we want to do is we want to animate the sprite again because we're not animating. So we can do that after we move. So down here, I'm going to move this over a bit so you can see this is inside the move state. We're going to call this control the sprite. Now we're going to look at better ways to actually control the sprite, but for now I'm just going to show you a kind of a straightforward way to do it, because later we're going to learn about arrays and things like that, and I'm going to show you a really neat way to control your sprites that works great for 4 directions and actually can be modified to work for 8 directional movement, and it's just super handy. It was actually Ryan from RM2K Dev that showed it to me, so I'm not going to take credit for that one. He's the one that came up with it, but I will teach it to you guys because it's really cool. So image speed, so we need to control the image speed. This one's a little bit tricky. We want the image speed to be 0.2, but only if we're moving. And the way we can check to see if we're moving is we can say sine length times 0.2. Now let me explain this a bit. The sine function will return either 1 or -1 based on the value of... Yeah, that doesn't actually work, does it? I think... Oh yeah, that works. Yeah, because this will basically just... Length is going to be equal to 2, right? Or maybe yeah, it's going to be equal to 2. It'll either be equal to 2 or 0. So this just turns... Well, we should just be able to set it to 0.2 then. It works. It's just not making sense in my head right now. So let's move on while I think about that for a second. I'll come back and explain it. So we're going to do if length is equal to 0, image index equals 0. There we go. What that does is it just means if we're not moving, right? Because if we're not moving up here, length is going to be equal to 0. If we're not moving, set our image index equal to 0. So the first image in our animation, so the standing one. Okay? Now let's do the next part, because this part does make sense to me. If v speed is greater than 0, so this is another check right here, another operator. We can check to see if something is greater than or less than. If our vertical speed is greater than 0, we're moving down, okay? So we're going to do sprite index equals sprite player down, because our vertical speed is greater than 0. There's another trick that you can do, which is called an else if. Else if. So it's like you're adding on to your last if statement. If your vertical speed is greater than 0, do this. Else, if your vertical speed is less than 0. If it's less than 0, we're moving up, right? Because negative in the vertical axis is up. So sprite index equals sprite player up. Okay? So this is our vertical sprites. Now let's do our horizontal sprites. Okay? If h speed is greater than 0, sprite index equals sprite player. Which one is it? It's right. If the horizontal speed is greater than 0, we're moving to the right. Okay? I could have done this as a mini challenge. That's okay. We'll have mini challenge in the next video. Sprite, let's see, not else. Else, if h speed is less than 0. Sprite index equals sprite player left. Forgot my semicolon on this one. So that should control the player's sprites. And like I said, this is kind of a temporary way that we're doing this. It's a straightforward way, right? It's pretty easy to understand this. If our vertical speed is greater than 0, our sprite, move down. If our vertical speed is less than 0, move up. It's pretty straightforward, this system, but I'm going to show you guys a slightly more complicated way later that is cleaner. It's just easier. The code is better, basically. At least in my opinion, it's better. Let's come back up to this right here and think this control the sprite. Let's think this through. If our image speed, yeah, that's not, because the sign of length is going to return either 1 or -1. And this one's just going to return 1 the entire time. So we should just be able to set it equal to 2. Image speed equals 0.2. Let's run that and see what happens. I'm looking at my reference code here and I'm like, that doesn't even make sense. I must have done something wrong for left. Let's come in and look. Oh yeah, I did up, move up instead of move left. That was ridiculous. Switch that. For the horizontal sprites, we want to move left, not up. Save it, run it again. Looking good. So you can see now that when we move at those angles that we don't move faster anymore. It's the same speed. Now, another thing that some of you mentioned was that your camera was you saw it as being a little bit jumpy. Unfortunately, we're working at we're so zoomed in right now that our camera is moving at pixels, and so it can't be perfectly smooth. If you want to make it a little bit smoother than it currently is, you can change this from, I guess I already changed it, but from point 0.1 to 0.3. I personally think 0.1 looks pretty good. I don't think it looks bad, but you can change it to 0.3 if you want to. It'll just make it move a little bit faster and maybe not look quite as jumpy for you. The other solution is that we scale everything in the game and just zoom clear out, but have everything scaled up. instead of zooming in. But that's a little complicated, so if you want to try and mess around with that route, you can, but I'm not going to explain that in this series. But this is looking really good. The movement feels nice. I can't wait to show you guys how to incorporate a Xbox controller for this. We'll be doing that in the next part 7. And then from there, we're going to be doing dashing in it. So we're going to be working more with states, finite state machines and stuff like that. So I'm really excited. I'll have another video out for it tomorrow. So thank you guys so much for watching. If you enjoyed this video, be sure and hit that like button and share it on Twitter. Those are the 2 things that help me the most. When you guys like it and share it on Twitter, that helps me a bunch. And I will talk to you guys later.